This is a really short one, but we can also look at limits at infinity analytically. In other words, without really having to look at a graph. Now, I do encourage you, if you want to get a more of a sense of this limit, graph the function y equals 2 over x plus 3, and then see what happens as x is going to infinity. But the main thing to understand here is as x goes to infinity, this denominator is the only thing that's changing, and in fact, it's getting extremely large. You know, if x is 1,000, the denominator is 1,003. If x is 1,000,000, the denominator is 1,000,003, and that's 2 is being divided by that. So imagine that you're trying to divide $2 among a bunch of people. You know, so if you divide it by 2 people, that's $1 a piece. If you divide it by 1,000,000 people, that means everybody's getting such a minuscule amount that it may as well be nothing. So one of my rules of limits is if you have 2 over a huge number, this limit goes to 0. And another way you could tell, I'm just going to draw a rough sketch of this graph. The graph would do something like this. There's a vertical asymptote somewhere over here at -3, and it does some other things. But we're concerned with what happens as x goes to infinity, which means to the extreme right, and that limit is 0. So a constant over something that's huge is going to go to 0. So in another video, we'll look at what happens when the numerator and denominator both have variables in them. It gets a little interesting, so make sure to stay tuned for that.